Hello? Am I audible? Hello? कोई रिप्लाई करो, am I audible?
Yes, ma'am. Audible. Yes, ma'am.
Okay. So good afternoon, all of you. I'm Pranjali Lute, Assistant Professor from General Engineering Department of Tulsiramji Gaikwad Patel College of Engineering and Technology. I'm going to teach you engineering mathematics subject for GATE examination. So first of all, today we are going to discuss about the syllabus of engineering mathematics for GATE examination. This is overall engineering mathematics syllabus. This is branch-wise topics for engineering mathematics. First one is civil engineering. Civil engineering is having these topics. Computer science and information technology is having these topics. Electronics and communication, electrical engineering, and mechanical engineering. This is overall syllabus of GATE examination for engineering mathematics. These are the books you have to use for GATE examination. Higher engineering mathematics author is B.S. Gravel, and GATE engineering mathematics made easy team. This is the marking scheme. Section A is having engineering mathematics compulsory questions, 7 questions of 1 marks each and 4 questions of 2 marks each. So total weightage for mathematics is having 15 marks and type of question is multiple choice question. So weightage on the engineering mathematics subject is having 15 marks. So today we are going to discuss the common topic of mathematics for GATE examination, that is differential equation. So first of all, we see what is the definition of differential equation. An equation involving derivative or differential coefficient is called as the differential equation. It means here we take one example of differential equation, that is d square y by dx square plus a square x equal to 0. So this is the example of differential equation. Here d square y by d square, this term represent y is a function of, here y is a function of x. Here y is equals to, here f of x, here y is equals to f of x, d square y by dx square, this represent y is a function of x. dy by dx plus 5y equals to 0, this is called the differential equation, and dy by dx represent y is a function of x. So here dy by dx, can we write dy by dx as y equal to f of x? So if we change the value of x, if we change the value of x, the value of y is also changes. Means y is totally depend on x. It means y is the dependent variable and x is the independent variable. Y is dependent variable and x is independent variable. So if we say that, what is meant by the differential equation? Involving derivative of y is dependent variable, derivative of dependent variable with respect to independent variable is called as the differential equation. So there are two types of differential equation. First one is ordinary differential equation and the second one is partial differential equation. There are two types of differential equation. So what is meant by for ordinary differential equation and what is meant by partial differential equation? See here, when a function involves one independent variable, then the equation is called as the ordinary differential equation. Here, d square y by dx square represent y is a function of x. D square y by d square represent y is a function of x. Means y is a function of only single variable x. Y is a function of only single variable x. Then we say that this is ordinary differential equation. Second one is partial differential equation. So what is mean by partial differential equation? An equation involves two or more independent variables. See here, del square y by del t square, and here is del square y by del x square. These represent this term and this term represent y is a function of t and y is a function of x. Means y is equal to function of two or more than two variable, here x and t, here x and t. So here function of x and t, it means this is called as the partial differential equation. In ordinary differential equation, y is a function of only single variable. That's why we call it as ordinary differential equation. And in this differential equation, y is a function of x and y is a function of t. Means y is a function of all more than two variable. Then we call it as a partial differential equation. And total differential equation is denoted by d dx, and partial differential equation is denoted by del x or del t. Next is order of differential equation. What is the order of that differential equation? Order of differential equation. It is defined as order of the highest derivative appearing in it. Here, d square y by dx square plus 5 dy by dx plus 10y. In this equation, you have to observe that highest derivative is d square y by dx square. This is the highest derivative. So here order of that differential equation is 2. In second example, 2 d square y by dx square plus 4 dy by dx cube plus y square plus 2 equal to x. This is another example of differential equation. Here is dy by dx and d square y by dx square. So in these two terms, d square y by dx square is occur in highest derivative. So what is the order of that differential equation? Order of that differential equation is here 2. 2 is the order of differential equation. In next slide, we discuss about the degree of differential equation. What is the degree of that differential equation? Here, highest power of the derivative occurring in differential equation means here 2d square y by dx square plus 4 dy by dx whole square plus y square plus 2 equal to x. In this differential equation, what is the highest derivative? D square y by dx square is the highest derivative, and power of that highest derivative is called the degree. So what is the power of that highest derivative? Power of this highest derivative is 1. So that's why we call here degree of that differential equation is 1. See next example. D cube y by dx cube whole square equal to 16 dy by dx cube plus y square. So in this differential equation, which is the highest derivative? Dy by dx? No, this is not the highest derivative. D cube y by dx cube is the highest derivative. So what is the power of that highest derivative? Power of that highest derivative is 2. So what is the degree of that differential equation? Degree of that differential equation is 2. But you have to note down one point. That point is, for calculating order and degree of the given differential equation, you must free your differential equation from radical and fraction. It means if your differential equation is having some power, so you having some power in fraction, so you have to remove that fraction, and after that you have to decide the order and degree of that differential equation. For this, note, we see one example. This is the example: d cube y by dx cube plus 4 under root of, this is a fraction, this is half, dy by dx cube plus y square equal to 0. So in this example, it is not possible to tell what is the order and degree of that differential equation, because this differential equation is having radical, having fraction, means power of that whole term is half. So you have to remove that power half. So how to remove it? First, we have to remove the radical. So how to remove this radical? Next, d cube y by dx cube, you have to shift this term in right hand side. So this will be minus 4 under root of dy by dx cube plus y square. Again, this term is having fraction, that is power is half. So we have to remove that power. Squaring both sides, we have to square here. So what about left hand side after squaring? D cube y by dx cube whole square equal to, what is the square of minus 4? 16. And take this square of second term. Here, d cube y by dx cube whole square equal to square of minus 4 is 16. And this term is having power half, and take the square of that term means half into 2. 2 getting cancelled. So this under root is getting cancelled. So your answer is 16 dy by dx square plus y square. Means this differential equation is free from fraction. So it is possible to find out the order and degree of that differential equation. So at the highest derivative, dy by dx cube is the highest derivative. So power of that highest derivative is the degree, means degree is 2, and highest derivative is 3. So what is the order and degree? Order is 3 and degree is 2. Order is 3 and degree is 2. See another example. Find the degree and order of that differential equation. Again, this differential equation is having a fraction, so it is not possible to tell the degree and order of that differential equation. So how to find out the order and degree? Here, this is the given differential equation. We have to shift this 1 by 2. We have to shift this 1 by 2 power in right hand side, so that will be reciprocal. So d cube y by dx cube to the power 5. Again, this equation is free from radical, so it is possible to find out the order and degree of that differential equation. Highest derivative, d cube y by dx cube is the highest derivative. Power of the highest derivative is a degree, and highest derivative is a order. So order of that differential equation is 3 and degree is 5. So degree is 5 and order of that differential equation is 3. Again, we see one example. Find the degree and order of that differential equation. So in this equation, again, this differential equation is having a fraction 5 by 3. So here again, we have to make this differential equation free from radical, and after that, you have to decide the order and degree of that differential equation. So then what we have to do here? This is the given differential equation. This is your given differential equation. So can we, how to remove this fraction, how to remove this power 5 by 3, how to remove it? Can we here multiply, we have to take the cube of that differential equation, cube of that differential equation. So 5 by 3 into 3. So 3 getting cancel. So your differential equation is y plus d to the power 4y, d to the power 4y upon dx to the power 4, and power of that term is 5 equal to d square y by dx square and d square y by dx square cube. Again, it is not possible directly to find out the order and degree. But in this differential equation, one thing we have to observe here, d to the power 4y upon dx to the power 4, this is the highest derivative. This is the highest derivative. Means with the help of this highest derivative, we have to decide the order and degree of that differential equation. So power of that differential, power of this bracket is 5. So after expanding this differential equation, we get power of d to the power 4y upon dx to the power 4 will be 10. After taking power of 5, so power is here 10. So order of that differential equation is 4, and this is the highest derivative, and power of the highest derivative is 10. After simplification it will be 10. So order is 4 and degree of that differential equation is 10. So here order is 4 and degree of that differential equation is 10 here. Next. Differential equation of first order first degree. First order first degree means differential equation is having first order first degree. For example, your differential equation is suppose dy by dx. Okay, suppose your differential equation is dy by dx. So dy by dx means order of that differential equation is 1 and degree of that differential equation is also 1. So that differential equation is called as the first order first degree. So we have to solve such type of equation having first order and first degree. There are some methods of solving the differential equation having first order first degree. So first one is variable separable equations. Variable separable means first we have to separate the variables of that given differential equation. Second one is homogeneous equation. Third is linear equation. And fourth one is exact differential equation. These are the some methods of solving differential equation of first order and first degree. So see some examples of variable separable equation. Variable separable equation means we have to separate the variables. So for this we take one example. Solution of the differential equation dy by dx equal to x square y with the condition y equal to 1 at x equal to 0. First of all, I will tell you what is the use of initial condition. Y equal to 1 at x is equals to 0. These are the initial conditions. And what is the use of that initial condition? Use of that initial condition is to find out the value of constant C which occur in your solution. So here write down differential equation dy by dx equal to x square y. Here right hand side is a combination of x and y. But I already told you First, we have to separate the variable because this is the example of variable separable form. So we have to separate the variable. So we have to shift this y in left hand side, and we have to shift this dx in right hand side. So this equation is dy by y equal to x square dx. In this equation, we observe that y and x, both variables are separated, so it is possible to integrate this differential equation. So we have to integrate left hand side and we have to integrate right hand side. So integration of dy by y equal to integration of x square dx. So what is the integration of 1 by y? Integration of 1 by y is log y, and integration of x square is x cube upon 3. So see here, log y equal to x cube upon 3 plus c. Whenever we have to shift this log in next side, that log will be converted into an exponential term. So this will be written as y equal to e to the power x cube upon 3 plus c. This is the solution of that given differential equation. But some initial conditions are given in the question. So what is the use of initial condition? Use of that initial condition is to find out the value of constant c. So y equal to, we have to separate the power e to the power c into e to the power x on 3. Here e to the power c means c log e. C log e. Log e is 1. So e to the power c is only c, e to the power x cube by 3, and this is the required solution of that given differential equation. But this is not your final answer because some initial conditions are given. So y equal to c e to the power x cube by 3. This is the solution, but the initial conditions are now x equal to 0, y equal to this condition is given. So put x is equals to 0 in solution and put y equals to 1 in the same solution. So y equal to 1 equal to c e to the power. Put x is equal to 0. So that will be 0 by 3. So this implies c equal to 1. So what is the value of constant c? Value of constant c, that is 1. So again, are you, what is the use of this initial condition? Use of this initial condition to find out the value of constant c. So what is the value of constant c? Is 1. So put this value c in the given answer. So that will be y equal to c means 1 e to the power x cube by 3. So y equal to e to the power x cube upon 3. This is your required solution. Then again, we see another example of separation of variable. Here, e to the power by dx x square dx equal to 0. Again, here we have to separate the variables. So this can be written as e to the power y dy equal to, we have to shift this term in right hand side. So that will be e to the power dy equal to minus square dx. Then here both variables are separate. So next step is to integrate sides. So for integrating, here write down the integration of e to the power by dy equal to minus of integration of x square dx. What is the integration of e to the power by? Integration of e to the power y is e to the power y, and integration of x square is x cube upon 3. So next, e to the power y, integration of e to the power y is e to the power y equal to minus integration of x square is x cube upon 3 plus constant c, and this is the required solution of given differential equation. This is all about separation of variable. Next, the differential homogeneous equation. The differential equation in the form dy by dx equal to f of xy g of xy. This is called the homogeneous differential equation. Means numerator and denominator both terms having degree same. So how to solve such type of equations? We have to solve this type of equations. Put y equal to vx or x equal to v according to your choice. Either you have to put y equals to vx or x is equals to vy. Then next step, after substituting y equal to vx or x is equals to vy, separate the variable v and x or v and y. We have to separate the variable, and after separating the variable, you know very well how to find out the solution by using separation of variable. So in that equation will be the solution. So how to solve this example? Method of homogeneous differential equation. Here let y equal to vx. Let y equal to vx. So put y equal to vx. So this equation is dvx upon dx equal to vx upon x plus tan vx upon x. Here d in place of y put vx, in place of y vx, in place of y vx. Then d dx of vx, d dx of vx, v and x both are differentiable. So both are differentiable, and whenever we have to take the derivative, then we have to apply here, yes, product rule. We have to apply here product rule because both terms are differentiable. First function v into derivative of x with respect to x is 1 plus second function x into derivative of first is dv by dx equal to, here x getting cancelled and here v plus tan x getting cancelled, so answer is tan v. So in this equation we have to cancel this v. After cancelling v, we get x dv by dx equal to tan v. Then again same thing we have to do here. We have to separate the variable. Without separating variable, it is not possible to find out the solution of that differential equation. So how to separate the variable? We have to shift tan v in left hand side, and we have to shift this dx upon dx in the right hand side. So that will be dx upon x equal to dv upon tan v. Here you have to observe that separate, both the variables are separated here, v and x both are separated. So we have to integrate this term. So after integration, left hand side, integration of dv upon tan v equal to integration of dx upon x. So here 1 upon tan is cot, 1 upon tan is cot. So first integration of cot v dv equal to dx upon x. Integration of cot is log of sine v equal to integration of 1 upon x is log x plus here both terms having log. That's why I consider here log c is a constant term. Then log sine v equal to log a plus log b. Log a plus log b can be written as log a into b. So here log getting cancel. So your answer is sine V equal to XC. Then we have to shift sign in right hand side. That will be sine inverse Cx. V equal to sine inverse Cx. And again we know that in place of V, we substituted there V equal to y by x equal to sine inverse Cx. And y equal to x sine inverse Cx. This is the required solution of that given differential equation. So this is your homogeneous differential equation. Next is exact differential equation. What does mean by exact differential equation and how to find out the solution of that differential equation? Here, exact differential equation. The differential equation is in the form m dx plus n dy equal to 0, and in this equation m and n are always in terms of x and y. So this is the exact differential equation, m dx plus n dy equal to 0. What is the solution of that differential equation? The solution of the given differential equation is integration of m dx, taking y constant, because here we integrate with respect to x, means in this integration y is a constant term, plus integration of terms of n not containing x. Not containing x means this term is having y, constant. But before that, there is one note: the necessary and sufficient condition for exact differential equation is, first you have to identify m, you have to identify n, and after identifying m and n, you have to calculate del m by del y, del n by del x, and if del m by del y and del n by del x both are same, so your differential equation is exact. You have to note down this point. What is the necessary and sufficient condition for the exact differential equation is del m by del y equal to del n by del x. If this condition is satisfied, then your differential equation is exact. Then after that, you have to find out the solution, and this is the solution of your differential equation. In next slide, we see we see how to find out the solution of that exact differential equation. See here, I already told you what is the form of differential equation, m dx plus n dy. See here, m dx plus n dy. So what is, compare here, m dx plus n dy. So m is x plus 1 e to the power x minus e to the power y. This is your m. And m dx plus n dy. So what is n? What is n? In next, n is equals to minus x e to the power y. First you have to, in exact differential equation, first you have to identify m and then identify n. After that, I told you what is the necessary and sufficient condition for the differential equation, del m by del y and del n by del x. So here we have to calculate del m by del y and del n by del x. So del m by del y, it means you have to differentiate this term with respect to y, taking x constant. So here in first term, x plus 1 is a constant term, e to the power x is also a constant term. So derivative with respect to y is 0 minus derivative of e to the power y with respect to y is e to the power y. So value of del m by del y equal to minus e to the power y. Next we calculate del n by del x. So differentiate with respect to x. It means y is a constant term because this is the partial derivative. So e to the power, derivative of e to the power y with respect to y is e to the power y. And derivative of minus x with respect to x is minus 1. So in this step, we have to observe that del m by del y and del n by del x both are same. means here both are same. So this is the sufficient and necessary condition for the exact differential equation. This condition shows that your given differential equation is exact, and if your given equation is exact, then we have to find out the solution. So how to find out the solution of that differential equation? Integration of m dx plus integration of terms of n not containing x. So here put the value of m. M is x plus 1 e to the power x minus e to the power y into dx plus terms of n not containing x, means in this n you have to observe that there is a single term, and this term whole term is containing x. This whole term is containing x, but your condition is terms of n not containing x. So there is no term not containing x. So here write down 0 dy equals to c. So we have to separate here integration of each and every term. X into e to the power x into e to the power x dx plus 1 into e to the power x e to the power x dx minus integration of e to the power y into dx equal to integrating constant c. Here x into e to the power x, there are two terms, and here is integration. So how to integrate this? By using integration by parts. So according to LIATE rule, x is the algebraic function and e to the power x is the second function. X is algebraic, e is exponential. LIATE, a means algebraic, so x is algebraic. LIATE, e is the last means exponential, so x is the first term and e to the power x is the second term. So you already learned how to find out integration by parts by using generalized integration by parts. How to find out by using generalized integration by parts? So here x is the first function, e to the power x is the second function. So first function x into integration of e to the power x is e to the power x minus derivative of x 1, derivative of x 1 into integration of second e to the power x, integration of e to the power x, e to the power x plus integration of e to the power x is e to the power x minus e to the power y is a constant term. So write down outside the integration, and integration of dx is x equal to c. So here minus e to the power x plus e to the power x getting cancelled, and your answer is x e to the power x minus e to the power y x equal to c, and this is the required solution of that exact differential equation. Next, fourth type is linear differential equation. First type is variable separable form, second is homogeneous, third is exact differential equation, and the last one is linear differential equation. So how to identify your linear differential equation? The differential equation is in the form dy by dx plus py equal to q. This is the linear differential equation. And here is having py. That's why P and Q are always a function of x, means P and Q are always in terms of x. So see here, there are some steps of solving this linear differential equation. First step is to identify P and Q, means you have to compare your given differential equation with this form and identify P and Q. After identifying P and Q, you have to find out integrating factor. So integrating factor, formula of integrating factor is e to the power integration of P dx. The solution of that given differential equation is y into integrating factor equal to q into integrating factor into dx plus c. This is the solution of that linear differential equation. So we take one example on linear differential equation. Here, the solution of differential equation. See here, dy by dx plus 2xy equal to e to the power minus x square. I already told you the right hand side, the differential equation is in the form dy by dx plus equal to q, and q are always in terms of x. So in this example, we observe that right hand side is in terms of x with y of 0 equal to 1. Again, this is initial condition. What use of that initial condition? Use of that initial condition is to find out the value of constant c. Yes. So here see dy by dx represent y is a function of x. Y is a function of x. So this is y of x equal to 1. So y of x. What is the value of x here? X is 0 and here y equal to 1. First, compare this given differential equation with the form dy by dx plus py equal to q. So what is the value of p? Y. Y को छोड़ दो, remaining term is 2x. So what is the value of p here? 2x. And what is the value of q here? E to the power minus x square. So here p equal to 2x, q equal to e to the power minus x square. Then first step is identify p and q, and then the second step is to find out integrating factor. So what is the formula of integrating factor? Integrating factor equal to e to the power integration of p into dx. P into dx. So put the value of p here. P is 2x into dx. What is the integration of twice x? 2 is a constant term, so write down outside 2, and integration of x is x square by 2. So e to the power 2 x square by 2, 2 getting cancel. So what is the integrating factor? E to the power x square is the integrating factor. Then we have to find out the required solution. So required solution is y into integrating factor equal to q into integrating factor into dx plus c. Y into, what is the integrating factor? E to the power x square equal to q is e to the power minus x square. Integrating factor is e to the power x square into dx plus c. So in this equation, e to the power minus x square, e to the power x square. Base is same. Base is same. It means we have to add these two powers. So minus x square plus x square is 0. This is e to the power 0, and e to the power 0 is 1. So y into e to the power x square equal to e to the power 0 is 1. So dx plus c y e to the power x square equal to, what is the integration of dx? Integration of dx is x. So y into e to the power x square equal to x plus c. This is the solution of that given differential equation. But again I told you, this is not your final answer, because one initial condition is given in your question, that is y of 0 equal to 1. So with the help of that initial condition, we have to find out the final answer. If initial condition is not given in your question, so this is your final answer. This is your final answer. But initial condition is given in the question. So with the help of that initial condition, we have to find out the value of constant c. So this is your answer. Again, initial condition are given. What is the initial condition? X equal to 0, y equal to 1. X equal to 0 and y equal to 1. So put the value of x as 0, e to the power 0, e to the power 0 is 1, y equal to 1, so here answer is 1 equal to x equal to 0 plus c. So what is the value of c here? By mistake here यहाँ पे 0 आ गया है by mistake. So this is 0 plus c. 1 into e to the power 0. E to the power 0 is 1. So what is the value of c here? C equal to 1. So we have to put that c equal to 1 in your solution. So what is the required and what is the final solution? That is y into e to the power x square equal to x plus c. Value of c is 1. So your required solution is y into e to the power x square equal to x plus 1. This is the required solution. So thank you so much. If you are having any queries, so you have to ask me. Any queries? Students, any questions from your side? Any questions? Yes? And beta, I tell you one thing. आपके एग्जामिनेशन में गेट के एग्जामिनेशन में एक कंपलसरी क्वेश्चन होता है. One compulsory question is there. Two, what is the degree and order of that differential equation? What is the solution of given differential equation? और मैंने आपकी differential equation के solution types ली, variable separable form, homogeneous, linear differential equation and differential equation. So one compulsory question will be asked in your examination. ठीक है, और डिग्री पर कंपल्सरी क्वेश्चन आता ही है. और दूसरा क्वेश्चन होता है differential equation is given and you have to find out the solution of that differential equation. दो क्वेश्चंस आपके एग्जामिनेशन में पूछते हैं. ठीक है, yes, any doubts?